Hello and welcome to my channel and welcome back to the series ConQuiz-2. Of course, we have some aim and particularly and mainly to support you preparing for exams for your board or university exams, including some competitive exams like IIT-JAM, NAT, GATE, SAQ, etc. And today our session 2 on general chemistry part 2. We'll be discussing today short answer type questions and numerical answer type questions NAT from IIT-JAM, of course with explanation. So let us start with SAQ, short answer type questions. The first question, electron volt EV is a non-SI unit of force or potential or something else, and what is its SI equivalent? So after every question, if you want, you can give pause, explore, ponder on the question, and when you get back, you get ready with your answer, you can get back to the video and run. So let me give you the answer. Of course, it is neither force or potential, it is the unit of energy. And as you know that 1 coulomb into volt gives you 1 joules, and 1 electron volt means the charge of electron in coulomb into 1 volt, and that gives you 1.602 into 10 to the minus 19 joules, or if you multiply by Avogadro constant, you will get 96.485 kilojoules per mole. The second question, in spectroscopy particularly, you often see that energy is expressed in some peculiar unit, centimeter inverse or meter inverse. So the question here that if energy is 1 electron volt, then you show or verify that this energy is equivalent to 8065.54 centimeter inverse. So how it comes centimeter inverse? As you know that E, if you divide or multiply by some universal constant like H or C, then actually you are scaling the energy. Of course, you will get it in different unit, and if you want to get back the earlier unit, then you have to just reverse your operation. That means if you divide by AC, then you have to multiply by AC at the end. So here we divide E by HC, and you follow the unit electron volt. So joule is numerator, and H in joule second, and C is meter per second. So joule and joule cancel out, second inverse cancel out. So it gives you simply meter inverse, and then you can convert it to centimeter inverse, and you can verify by calculator. The answer is exactly 8065.54 centimeter inverse. So the next question, it's a trivial one maybe for some of you. How many electrons can be put in each of the following? A cell with principal quantum number n. So as you know, it is 2n square, but how it comes 2n square? If you want to split the answers, for every n there are l's, quantum number l, 0 to n minus 1, and for each l there is ml, another quantum number, minus l to plus l. That means a total of 2l plus 1 number of ml values for each l, and for that means for a given n, what is the total number of ml values? It is simply sum over 12 plus 1, 0 to n minus 1. So it gives you 2 summation. The first sum by simple formula, it gives you 2 into n minus 1 by 2, and the second one is n number of 1, that means simply n. So finally you give you get it n square, right? And for each ml value there are 2 electrons, that means the orbital concept. So finally you multiply it by 2, and the answer is 2n square. The second one, a subcell with quantum number n and l. So again, for L there are 12 plus 1 number of ml values and 2 electrons for each ml. So it gives you 2 into 12 plus 1, 4l plus 2. An orbital, of course, it is specified by an ml value, so 2 electrons are there. A spin orbital is ms either plus up or minus, so it is a single electron. I think you have got the point. Another one, it's a trivial, but very often we do this mistake. At STP, 1 mole of an ideal gas is 22.4 liter. Have you ever measured it experimentally? No, it's not possible. It can be obtained from, of course, the theoretical equation PV equal to NR. But my question is that what values of P, T, and R to be used? So very often I've done this experiment with my students, that the answer comes like P is 1 sir, T is 273, and R is 8.314. that they are used to give very often and frequent. But if we just put it in the nRT by P, we will not get 22.4 liters. But the correct thing is that we are putting a wrong R value. Since it is in liter, so it should be liter atmosphere per Kelvin per mole, and you can see easily that if R is 0.082, then only you will get 22.4 liter. And if observe carefully the unit, how they cancel out each other, and finally gives you the liter. Okay. Now, do the terms H nu and nRT represent the same quantity? How? Yes, of course, they are energy both. H nu, just by dimension or unit, you can say that H is joule second and nu is second inverse, so it gives you joules. And nRT, so n mole, and R is joules per Kelvin per mole SI unit, and T is in Kelvin, so finally it gives you again joules. So both are energy. Well, that's a separate kind of questions, conceptual of course. In an attempt to combine Boyle's and Charles' law, one follows that okay, PV equal to constant is Boyle's law and V by T is constant, Charles' law. So equal multiply equals. Applying that condition, you can get by multiplying PV into V by T left hand sides to get C1 into C2, that is another constant. So you get PV square by T, PV square by T is constant, but ideal gas is PV by T is constant. So the question is, what is the fallacy, right? There is no fallacy actually, because the operation you are doing, multiplying equals multiply equals, that is not applicable here, because the two laws, Charles and Boyle's, they apply under different conditions. The first one is under constant temperature and mass, and the second one at constant pressure and mass. So you cannot multiply like this. Okay. For oxygen, given the molecular weight, give the molecular weight, the molecular mass, and the molar mass with proper units. So often we get confused. One has to be very clear about this, that 32 is the molecular weight. It's a relative something, so no unit is there. But molecular mass is 32 AMU, or if you want to convert it in grams, then you just multiply by 1 by Avogadro constant. And the molar mass is actually, so 32 gram per mole, so per mole, that is the molar mass, right? So 32, 32.0 AMU and 32 grams per mole, these are very clearly different. For pure hot water, pH is less than 7 because water dissociates higher temperature. So more H plus you will get, and the concentration of H would be less than 10 to the power minus 7. So pH would be obviously less than 7. So pH less than 7. So is it acidic? The answer is of course no, because even in that condition, the concentration of H plus and OH minus, they are the same. So it cannot be either acidic or alkaline, right? Only the scale is different. That means pH 7 is not the neutral water pH, rather it is something slightly less than 7. So that is the point here. Now let us go for the numerical answer type questions taken from IIT-JAM last few years. The first question: in the gas phase, the ratio of excluded volume of molecular volume for a spherical molecule is. So what is the answer? Let me give you the answer first. Now you can give a pause, try on your own, and when you are ready, come back with the video. But now I am giving you the answer. So excluded volume, you know, in real gas postulates, the molecule itself has some volume, right? So that volume is not accessible by any other molecules, right? So that is the excluded volume. Now the question is, what is the value of that excluded volume that a single central molecule is responsible for? So it is visible that if you think of a central sphere or circle, and all around there are other molecules, other spheres. So you can see that R plus R, this 2R, if you draw a central circle with radius 2R like this, or more visibly here. So it is 2R, the inner red circle, surrounded by the black circles, that means black other molecules, and the radius is of course R plus R 2R. So the blue circle or sphere, that volume is actually excluded volume, because the minimum distance between the black circle and the red circle, it is 2R. So a second molecule cannot come within, less than, the distance between two centers cannot be less than 2r. So the blue cycle or circle or sphere actually, that volume is the excluded. So let small v is the volume of the molecule itself, 4 that pi r cube, and capital V is the volume of that excluded volume circle. So 4 that pi 2r whole cube, and that means 4 that pi 8r cube. So if you take the ratio, you will get simply 8. So the answer is 8. Next question: the amount in grams of potassium dichromate present in 75 ml of 0.16 molar aqueous solution is. So again the answer is 3.5 to 3.54. Molar mass is 294 gram per mole and concentration is given. Volume is given in ml, so I convert it into liter. So the number of moles is V into C, that is 0.012 mole. And now if you want to convert into grams, you have to multiply by molar mass. So 0.012 into 294. So answer is 3.528 grams. Okay. The next question: acetic acid content in commercial vinegar was analyzed by titrating against 1.5 molar NaOH solution. A 20 ml vinegar sample required 18 ml of titrant, that is NaOH, to give endpoint. The concentration of acetic acid in the vinegar in moles per liter is. So it's going to be an application of that very famous formula: V1 H1 is V2 H2, and here V1 18 ml, 1.5 normal, that is the NaOH, and the right hand side 20 ml vinegar, and strength is unknown. So you will get in normality, that is equivalent per liter. Of course, you can see the answer 1.35. And to note that acetic acid and NaOH, both cases, one normality is equal to 1 molar, because you have to calculate in normality, right? Next question: the isotope undergoes one alpha and one beta particle emission sequentially to form an isotope X. So the number of neutrons in X is, well, so that is given, that alpha, beta and X unknown with M charge and N mass. So what we will do, you will just balance charge and mass separately. So you will get two equations actually. For mass balance, it is 214 minus 4, that's 210. So N is 210, and charge balance 84 minus 2 minus of minus 1, that is 83. So X is clearly 83 x 210. Of course, the number of neutrons is 210 minus 83, so 127 is the answer. I think it's clear to you. So the next question: hydrolysis of 15.45 gram of benzonitrile produced 10.98 grams of benzoic acid. The percentage yield of acid formed is. So it looks very simple unitary method problem, but one trick is there, that you have to know the molecular mass of benzonitrile and benzoic acid. That means you have to know the molecular formula first, and so you have to convert from gram to number of moles, and then you can calculate by using the unitary method the percentage yield. So let us do that. The answer is 60. Let us see how it comes. Benzonitrile is like this. So M is 103.04 gram mole per mole, and so the number of moles is given mass in grams divided by gram per mole molar mass, so 1.15. And benzoic acid similarly, it gives you 0.09 mole. So now you can calculate the percentage, 0.09 by 0.15 into 100. So that gives you exactly 60. So that is why the answer is 60. The next question: a vessel contains a mixture of hydrogen and nitrogen gas. The density of this gas mixture is 0.2 grams per liter at 300 Kelvin and 1. Assuming that both the gases behave ideally, the mole fraction of nitrogen gas in the vessel is something. So what is that mole fraction of nitrogen? Okay. So let us see how it can be solved. So rho we know that mass by volume. Now mass, total mass. So that means N1 number of say hydrogen and N2 numbers of nitrogen, and V is nRT by P, ideal gas equation, and N is the total number of moles, right? nRT by P. Now M1 is 2 for hydrogen molar mass, so it is 2x1. Why x1? Because I am dividing N1 and N2 by N, so I will get x1 and x2. So 2x1 and M2 molar mass is 28 for nitrogen. So 28x2 is equal to 0.2. And then x1 is, you know, mole fraction 1 minus x2. So I'm putting 1 minus x2 for x1, and it's a single variable equation now in unknown x2, and you can solve it to get, because p and t are given, so you get x2 is 0.113 without any unit mole fraction. So that is a tricky question, numerical question. The next one, assuming ideal gas behavior, the density of oxygen gas of 300 Kelvin and 1 atmosphere is this. So again, it's using some kind of equation PV propane at T. So the concentration density N by V is P by R, right? Now P is given 1 atmosphere, and R, of course, here you have to use 0.082 and temperature 300 Kelvin. So this finally gives you moles per liter, but it is wanted in grams per liter. So of course you have to multiply this number by 32 to get grams per mole, because it is oxygen. So 32 by this, and you finally get the answer 1.3008 grams per liter. Got it? Thank you. The next question is from radioactive decay. Sodium 24 decays to 1/4 of its initial amount in 29.8 hours. Its decay constant is this. So how to solve this problem? Now you know that sodium decay is a first order kinetics, and for first order kinetics, it doesn't depend on the initial concentration. So if you start with C, then after T half it becomes C by 2, and after same T half value it becomes C by 4. These two T halves are exactly the same. So 2 T half is equal to 29.8. So T half you get 14.9 hours. Now the final formula, that K rate constant is ln2 by T half. So we get answer 0.04652. So please check it by using calculator. You won't have to believe me, you do it on your own. Let me go to the next problem. The nuclear spin quantum number I of a nucleus is 3 by 2. When placed in an external magnetic field, the number of possible spin energy states it can occupy is. It's simply one line formula. You know that 2I plus 1 is the number of spin states if I is the spin quantum number. So I is here 3 by 2. So 2 into 3 by 2 plus 1, it gives you 4. Next question. Okay, you can give any time pause to the video and take some rest. You can come back again, but let me continue. The volume of 0.3 molar ferrous ammonium sulfate required for the completion of redox titration with 20 ml of 0.1 molar potassium dichromate solution is how much ml, right? So again, it's going to be an application of V1 S1 V2 S2, but this time you have to be careful, because you have to calculate in normality, but here the molarity is given, so you have to convert it properly. Particularly for dichromate solution, you have to know the reaction, how it occurs. So it goes like this, and of course it is not balanced, so you have to add H plus ions and electrons properly, so that you can have a balanced ionic equation, and that gives you balance. So 6 electrons are needed, so that's why 1 molar of dichromate is actually 6 normal of dichromate, right? So you have to use that 6 in your calculation, otherwise it would be wrong. So now we apply V1 S1 V2 S2. So 20 ml dichromate, 6 written in red color. So 6 into 0.1, now normal is 0.3. It was molar, but for ferrous sulfate molarity and normality are the same. So 0.3 into V2, that is the unknown, and you can calculate V2 from this equation to be exactly 40 milliliter. So I think you can check it again with your calculator. 1 liter of a buffer solution contains 0.004 mole of acetic acid. This pKa value is given 4.76, and 0.4 mole of sodium acid. The pH of the solution is 1. So it is an application of famous, you have to remember please, and this equation, Henderson equation. pH is pKa plus log of concentration of salt by concentration of acid. So here all the terms are given on the right hand side. So you just put it, and you will get the value 6.26. Okay, so you can check it please. Film of stearic acid partially covers the water surface in a container. The work needed to decrease this coverage by 1 centimeter square follow the unit, is 25 into 10 to the minus 7 joules. Again, follow the unit. This is SI. The surface tension Newton per meter of the film is this. So it's mixed up units. You have to convert it properly. The problem. So this is the formula that energy related to the area change, and gamma minus gamma star. Gamma star is the coverage, film surface tension, and gamma is the water surface tension that is given also. So both, now you can apply the dW is given in joules, no problem. But on the right hand side, dA area is given in centimeter square, so that is 10 to the minus 2 meter square. That you have to be careful at this point. And then you can solve a single unknown gamma star, and gamma star would come as 0.04 into 2 0.05. So that is the answer. Well, this is a very trivial one. The value of N in PnO18 6 minus is. So it's a balance, charge balance. How we can do? You have to know that P is in plus 5 oxidation state. So 5 into N plus 18 into minus 2 oxidation state of oxygen, and that gives you final overall charge 6 minus 6 minus 6. So the answer is N is 6. So that you can easily get. Seawater containing 1 molar NaCl has to be desalinated at 300 Kelvin using a membrane permeable water. So it's talking about osmosis. The minimum pressure in bars required on the seawater side of the membrane is this. So how to crack that? Of course, the equation is pi equal to ICRT. I is in red because it is the event of factor, and for this case NaCl gives you 2 ions, so Na and Cl, so I is 2, and you just put the value, other values, the concentration is given, but it is given moles per liter, but the SI unit of volume is meter cube, so I have converted centimeter 1000 centimeter cube, that means 1 liter, into meter cube, that is 10 to the minus 3 meter cube, and the rest of the things are as usual in SI unit. So the unit finally comes in SI in Newton per meter square. So the answer is 49.7 to 49.9. If you include I, but if you are interested in the theoretical value, not the experimental or observed value, then I will be omitted, and then you will get the answer. The other answer was given in the answer 24.855. The longest wavelength of light absorbed by a hydrogen-like atom is 2.48 nanometer. The nuclear charge of the atom is 1. Okay. Now how it comes in. So this is the energy expression that is very popular with you. RH is the Rydberg constant. Now M and N, two different levels. So for the longest wavelength, that means the shortest frequency, you have the option, only one option, that is M has to be the ground level 1, and just next to is the N. So it comes from N equal to 2 to 1. That would give you the smallest frequency. So just put the values, and note that everything is given in meter inverse unit. And the Rydberg is given in centimeter, you can convert to meter, and the wavelength is also given in meter, so 1 by lambda is meter inverse. So you can use these values on the equation to get Z square is 49, so Z becomes 7. Okay. So thanks for watching. Our next video would be on general chemistry, but the last part, that is session 3, and that will be coming soon. And in that video, we will be discussing MCQ and MSQ, all taken from IIT-JAM. So please keep on watching, comment or suggest on whatever you think of, particularly how we can improve our video quality or content quality, how I can serve you better. Please do subscribe and encourage your friends to subscribe and watch the video. Thanks once again. Thank you.